This video will discuss transformations to standard form quadratic equations. These transformations can also be thought of as parameter changes because you're going to be changing the digits on the equations that you have. In our first example, we're given the graph of the quadratic parent function on the coordinate grid, which is the equation y equals x squared. And it's telling us that we are transforming this to create the graph of y equals 2x squared. And our task here is going to be to describe the changes that we made to our quadratic parent function. Looking at our quadratic parent function compared to standard form of quadratic equations, our a value, which is the value that is in front of your x squared term, is 1. So let me rewrite this to the side. They're giving us originally a value of 1. Looking at the a value in the new equation that we're going to graph in a second, the a value is 2. So when we describe our changes off to the side, we're going to have to describe how does an a value going from 1 to 2 affect the graph of my quadratic equation. Okay, so if we're going to sketch the graph of y equals 2x squared, we have to go back to our understanding of graphing quadratic equations. So if you don't remember that, there is a video from last week that will review how to graph quadratic equations. The very first point that I want to graph, if I want to stay consistent what's here, is I want to find my vertex point. The vertex is always the most important part when we're talking about these parameter changes or transformations, because everything happens or is central about the vertex. So how do we find the vertex of y equals 2x squared? Well, our vertex is equal to negative b over 2a. There's also a video on how to find the vertex from last week as well. And looking at our equation, y equals 2x squared, and comparing it to standard form, the b value happens in front of the x term. For us, we don't have a b value, so when we go to substitute, we have negative 0 over 2 times, and we know that our a value is 2. This will, however, give us a 0 for the x-coordinate of our vertex. And then if we substitute that into our equation, that will also give us a 0 for the y value as well. So if we complete our table when trying to graph our function, we know 0, 0 is there. Let's stay consistent with the graph that we have and use negative 1 and positive 1 on either side to figure out those points. So I'm going to graph my vertex already on the coordinate grid. It's right there on top of the vertex of the parent function. And then to get negative 1's y value, I am going to substitute. So 2 times negative 1 squared, which should give me 2. So I'm going to do negative 1 in the x and positive 2 in the y. And then if I'm going to substitute in 1, hopefully we remember from our previous lessons that quadratic functions are symmetric, so we should get 2. The math works out. So when we go 1 in the x and 2 in the y, and then I'm going to graph this guy. So we have transformed our parent function y equals x squared to a new graph y equals 2x squared. And one thing that we can see is that it stays at the same point. It doesn't transform or move up or down. But what does happen is it's like our graph got a little bit more narrow. So that's the change that we can describe, is that our graph gets more narrow or narrower. This change may also be called a vertical stretch. So when we make our graph more narrow, it's like we're taking our graph and stretching it along the y-axis. So I'll come over here and draw my vertical axis. So it's like we take our parabola and we stretch it across the y-axis. So that's why when you make your graph narrow, it's like a vertical stretch. All right, so that is changes strictly to the a value. You made your graph become more narrow or a vertical stretch from going from a 1 to 2a value. Later on in this video, we're going to be going to a smaller a value and seeing how that affects our graph. All right, let's look at our next task. The graph of y equals x squared is shown on the grid, and we're going to call this function q. The vertex of graph W is 2 units above the vertex of graph Q. And here's our task this time. We need to sketch the graph of function Q. Okay, so looking at our quadratic parent function, we have y equals x squared. And its vertex is starting at 0 on the y-axis. Looking at standard form of equations, we see a plus c in the back, and that plus c is telling us where we are starting or how we're transforming, along the y-axis. So for this equation, we have simply y equals x squared, but this is technically y equals x squared plus 0, if we want to be technical. Okay, so if we're trying to get graph W, we're going to take this 0 starting point and go 2 units up, which lands me right there. Intuitively, if we're traveling up the y-axis, that is going to give me a plus 2. So my new equation, or my transformed parent function, will now be y equals x squared plus 2. And we can sketch the graph of that function the same way we sketched the graph of our other one. So I'm going to come over here and make a table of my x and y's. I know I'm going to use 0, -1, and 1. Those are quick points to use here. From our graph already, or the start of our graph, we know that our vertex is 0 in the x and 2 in the y. So that one's already done for us. When we figure out what -1 is, so -1 squared plus 2, that should give us 3. And then quickly we can understand that if we substitute in +1, we should get 3 as well. So -1 and 3 and +1 and 3. And we're going to sketch our new graph. All right, so strictly changes into the C value, or the number that you are adding, or you could be subtracting in the back, will make your graph shift up if you're going to be adding a number, or if you're going to be subtracting a number, your graph is going to shift down. All right, and let's move on to our third and final task. The graph of the quadratic parent function is transformed to create the graph of y equals 1/2 x squared plus 3, and we're going to have to describe changes made to our graphs. So this time we already have the graphs there for us. We just need to compare the equations and kind of look at the graphs that are there to see what is happening to our quadratic parent function. So we know our quadratic parent function is y equals, I'm going to fill in the 1 for the a value, y equals 1x squared. Technically it's just x squared, but we know we need to look at a value, so let's put that invisible 1 in. And then our new equation is y equals 1/2 x squared plus 3. Well, the first type of transformation that we learned about is changes in the a value. So our a value went from a value of 1 to an a value of 1/2. I'm going to draw a separate number line over here so that we can have a better reference of where these numbers are in comparison into 0. So Here we have 1 and then we have 1/2. If you notice, our A value is getting smaller and it is traveling closer to 0. If we look at the graph of our parent function being transformed to our new equation, I'm labeling the functions here for us. It looks like our graph, like we pressed it down and it got a little bit wider. So as we travel closer to 0, this time that makes your graph become wider. So that's the first change that we can describe, is that our graph became wider. And instead of like I'm stretching the graph vertically, this time it's like I'm taking my graph vertically and I'm doing a compression, like I'm pressing it down. So that's the first change we can see strictly off of the A value. Now, looking at our C value, well, we know, like I said in a previous slide, that our quadratic function, our quadratic parent function technically is y equals 1x squared plus 0 if we really want to be super technical. And looking at our new equation, it's plus 3. So how does going from 0 to plus 3 affect our graph? Well, it made our graph shift up 3 units. All right, so hopefully we better understand how an A value can make our graph become more wide, which is a vertical compression because you're compressing it down, or it can make your graph become more narrow, which is like a vertical stretch, like you're pulling your graph. And our C value is how we travel along the y-axis, whether we're going up or down. We're going to add or subtract the number to the back of our equation.